Hello and welcome. My name is Alexander Moreira with AlphaStar Academy, and today we're going to be discussing the problem It's Mooing Time, Part 2. This problem is from the January 2025 USACO contest. And in this problem, we are given a large array of integers, and our objective is to count how many distinct moos appear in the array. So a definition of a moo in this problem is a pair of distinct integers I and j. So that means I and j cannot be equal to each other, such that two copies of j appear anywhere to the right of I. They don't necessarily have to appear to i's immediate right. As long as they appear somewhere to the right of I, it's a moo. So let's make this concrete with an example. Here we have an array with 8 numbers in it, and we want to count the distinct moos. So let's just look at each number that appears in the array, starting with 1 and going all the way to 5. So we're going to look at what moos start with 1, then what moos start with 2, and so on. So when it comes to 1, we can see that there are 3 threes that appear to the right of 1, namely these 3. So that is enough to say that there are 2 copies of 3 to the right of 1. So one example of a moo here would be the pair 1, 3. 2 copies of 3 appearing to the right of 1. Same thing for 4. 1 appears here, and 2 copies of 4 appear to its right. So that would be another distinct moo. Let's look at 2 now. 2 has, again, the same values. 3 appears twice to its right, and 4 appears twice to its right. So we get 2 more distinct moos for the value 2. We get 2 and 3, and 2 and 4. If we move on to 3, 3 cannot be counted with itself. So note that there are 2 3s to the right of the first 3, but I and j have to be different. So here, the only valid moo for 3 would be 3 paired with these 2 4s. So that would be 3 comma 4 is another distinct moo. 4 has no distinct moos where it starts as I, and that's because no value appears twice to the right of the first 4. Same thing with 5. No value appears twice to the right of the first 5. So these are all of the distinct moos, and our output would be 5. So how do we solve a problem like this? Well, one thing I like to do is start by going through several examples. So here we have another example with the values 1, 2, 3, and 6. And here are the distinct moos. So we have 1 and 2. We've got 1 and 3. We've got 1 and 6. We've got 2 and 1. We've got 2 and 3, 2 and 6, and 3 and 6. So one thing that we can learn from this example is sort of what values of 1 are in some sense important to look at. For example, if we look at this one right here, we see that to this one's right, there is only one number that appears twice, 6. To this one's right, there are 2 numbers that appear twice, 3 and 6. To this one's number, there are 4 numbers that appear twice, 3 not counting 1 itself, right? Because we can see that 1 appears twice, so the numbers that don't include 1 are 2, 3, and 6. So if we look at the leftmost one, that's going to include as many possible moos that start with a 1 as possible. So this leads us to our first key observation, which is we only need to look at the first instance of each number. So we're going to look at the first 1 and count how many moos are associated with the first 1. Then we're going to look at the first 2, count how many numbers or how many moos are associated with the first 2. Then we look at the first 3, count how many moos are associated with the first 3, and then look at the 6, count how many moos start with the first 6. So this simplifies the problem because we only need to look at the first value of each number. So given that we only need to look at the first instance of each number, what do we want to know for each of those first instances? Well, we want to know the number of numbers not equal to the current number that appear at least twice. And in order to achieve this, what we can do is we can loop over the array backwards. And as we traverse the array from right to left, we will record the number of numbers that have appeared twice so far. So for example, right here, one number has appeared twice. Now two numbers have appeared twice. Now three numbers have appeared twice. Now four numbers have appeared twice. And every time we get to the first instance of a number, or if you're looping backwards, the last instance of a number, then we will increase our count by the number of numbers that occur at least twice to the right of the current number. So this means the rough outline of our code will be as follows. We're going to loop I from n minus 1 to 0. We are going to check. We're going to first initialize some counter storing sort of the number of numbers that appear at least twice to the right of the current position. If a value AI, so where A just denotes the array I, is appearing for the second time, then we're going to increase doubles by 1, saying, okay, we found a second copy of this value, so now going forward in perpetuity, we're going to know that there are at least 2 copies of AI to the right of my current value. And then if AI is appearing for the last time, so this would be the leftmost value of AI, then we will increase our output by the current value of doubles. So output plus equals doubles, and then we print output out the end. Now, there is a small bug in this program, which is we do not account for what happens if the number itself, say we're currently looking at 1, what happens if the number itself appears twice to the right of the number? In that case, you would have to subtract 1. Otherwise, you're overcounting, right? I and j are not allowed to be equal to each other. So we will handle that case when we write the code in full. As for checking if AI is appearing for the second time, well, we can use a frequency array to do that. So we will use a frequency array. Every time the frequency of a value hits 2, then we will increase doubles. To check if AI is appearing for the last time, we can use a second frequency array, which has pre-computed the total frequency of each value. And when the frequency of AI reaches the total frequency of AI in the array, then we have learned that we're seeing AI for the very last time. So we'll increase our output. And that completes our analysis of the problem. Let's go jump into the code. All right, we've begun here by reading in the value n and the array of values. This is just a length n integer array. And now we're ready to begin declaring our variables. So we have a frequency array 1. This is going to store all of the frequencies of the numbers in our first pass over the array. So this is going to be our pre-computation step. And then we're going to have a second frequency array storing the frequency of all of the numbers in our backward pass. So we actually have to do 2 passes over the array here. So pass 1 is just the idea that we want to pre-compute all of the frequencies so that in our second pass, we can tell if a number is appearing for the last time. There are other ways of solving this. You could also store the first index of each number in advance in maybe a map or something like this. But this works just as well. So we just loop over all the numbers. Every time we see the number AI, we're going to increase the slot AI by 1. So this creates a histogram of the frequencies of each number. And now we're ready to begin our second and final pass over the array. And this one is going to be looping over the array backwards. So we're going to declare two variables, output, which stores our final result, and doubles, which stores the number of numbers that have appeared twice so far. And now we can begin our loop backwards over the array. So this is just saying that n is going to start at position n minus, or I is going to start at position n minus 1 and go to position 0. The first thing we're going to want to do for a value ai in this loop is increase its frequency in the second frequency array. So we're counting the frequencies of all of the numbers starting from scratch. Then we want to check if we're seeing AI for the second time. If we are seeing the value AI for the second time, that corresponds to its frequency in the second frequency array being 2. And if the frequency is 2, we'll increase doubles by 1. So this is just saying that in the future, all numbers have at least 2 copies of AI to the right of their current value. Next, so that's this part of our outline. And then our final portion of our outline got a little deleted here. We're going to check if AI is appearing for the last time. And if it is, we're going to increase output by doubles. So we're going to check, is this the last copy of AI we will see? And how we know that is if the frequency of AI in the second frequency array is equal to the frequency that we pre-computed for all of the numbers, then we know that we've seen the last AI. We're not going to see any more AIs, so we should increase our output by the current value of doubles. So if the frequency of AI is small, in particular if it's 1, then we know that it won't appear twice to the right of itself. So we can increase the output by every single value to the right. So we don't have to worry about this case where I is appearing, or the value AI is appearing to the right of itself. We can just increase by all of the numbers. However, if it's large, right, if the frequency is at least 2, then we know that AI has contributed to doubles. So we should only increase the output by doubles minus 1. Notably, AI cannot be paired with itself. And then we print out the output and we are done. So this is the full credit solution here. There are also partial credit solutions where you sort of record the same exact information, but in a less efficient manner. And I always encourage people to start with those partial credit solutions and build their way up to a full credit solution like this. So thank you guys so much for watching the video. I hope it was helpful. See you in the next one. Bye bye, everyone.